How does the for each loop work in Java? Introduction. One of the most commonly used loop constructs in Java is the for each loop. It is also called enhanced for loop. The for each loop is used to iterate through arrays, traverse collections, read elements sequentially. It provides a cleaner and simpler alternative to traditional for loops, iterator-based loops. Example: int numbers equals 1, 2, 3. For int n in numbers. System.out.println n. Output 1, 2, 3. This topic explains what the for each loop is, how it works internally, syntax, arrays and collections, iteration behavior, limitations, performance considerations, common mistakes, best practices. This is a foundational Java language feature. What is a for each loop? The for each loop is a simplified loop used for iterating over elements in a sequence. It automatically accesses check one element at a time without manual index handling. Basic syntax for data type variable collection. Use variable structure. Part meaning data type, type of each element, variable current element, variable collection, array or iterable object. Example with array. Int numbers equals 10, 20, 30. For int n numbers, system out println n. Output 10, 20, 30. How it reads. Example: for int n numbers can be read as for each int value, n inside numbers, traditional for loop equivalent. The previous example is equivalent to for int I equals 0, I greater than numbers length, I++. Int n equals numbers I, system out println n. The for each loop hides DOM index management, boundary checking, making code cleaner. Example with strings, string names equals John, Alice, Bob. For string name names, system out println name. Output John, Alice, Bob, using for each with collections. The for each loop works with arrays, collections implementing iterable. Example with array list. List string fruits equals new array list. Fruits.add apple, fruits.add banana, fruits.add orange. For string fruit, fruits, system out println fruit. Output apple, banana, orange internally uses iterator. For collections, the for each loop internally uses iterator, conceptually similar to iterator string it equals fruits.iterator, while it has next. String fruit equals it.next. System out.println fruit a. The enhanced loop simplifies this process. Arrays versus collections. Arrays uses index-based iteration internally. Collections uses iterator internally. Example flow. Example concept. Collection iterator created. Has next, next. Repeat read-only nature. The loop variable is usually check, a copy, reference to current element. Changing the variable itself does not modify the array. Example int nums equals 1, 2, 3. For int n nums, n equals 100. Output array remains 1, 2, 3. Because check, n is only a temporary variable. Modifying objects. For object references, list user users equals for user u users. u.setName updated. This does modify objects because object references point to same objects, cannot access index directly. Example: for string s names, No index variable exists. Cannot directly access. Current position. When traditional for is better. Use regular for loop when you need. Indexes. Reverse iteration, element replacement, skipping logic with indexes. Example. Need index for int I equals 0, I less than names.length. System.out.println, I plus names I. Removing elements problem. Incorrect. For string s. List.remove s. May cause. Concurrent modification exception. Correct removal using iterator. Iterator string it equals list.iterator. While it has next. String s equals it.next. If s equals apple, it.remove. Nested for each loops. Example. Int array matrix equals 1, 2, 3, 4. For int print a row in matrix. For int value row. System.out.println value. Output. 1, 2, 3, 4. Performance considerations. For most applications, current performance difference is minimal. The for each loop is usually preferred for, readability, maintainability. Primitive arrays. Works well with primitives. Example. Double L prices equals 10.5, 20.3. For double P prices. System.out.println P. Custom iterable classes. Custom classes can support for each by implementing iterable T. Example concept. Custom class implements iterable usable in for each example with set of string cities equals new hash set. Cities.add Toronto. Cities.add London. For string city cities. System.out.println city. For maps map string integer map equals new hash map, For map entry string integer entry map entry set. System.out.println entry.getKey. Common beginner mistakes. 1. Trying to modify primitive array elements.
Wrong expectation.
For int n nums n++. Original array remains unchanged. 2. Removing elements during iteration may throw. Concurrent modification exception. 3. Expecting index access. For each does not provide indexes directly. 4. Using wrong variable type. Wrong. 4. String n numbers. Type mismatch causes compilation error. Best practices. Best practices include: use for each for simple iteration. Use traditional for when indexes are needed. Use avoid modifying collections during iteration. Use prefer readability over unnecessary optimization. Use iterators for safe removal. Advantages of for each: cleaner syntax, fewer bugs, no manual index management, easier readability, safer iteration. Limitations of for each: no direct index access, difficult element replacement, cannot easily iterate backward, unsafe direct collection modification. Simple definition: for each loop. A simplified Java loop used to iterate through arrays and collections one element at a time. Simple definition enhanced for loop. Another name for the Java for each loop introduced to simplify iteration. Final summary. The Java for each loop provides a cleaner way to iterate through. Circle arrays, collections, iterable objects. Example. For string name, names, system.out.println name. Internally. Check. Arrays use indexed access. Collections use iterators. Key idea. The for each loop simplifies iteration by automatically visiting each element one at a time. Understanding the enhanced for loop is essential for writing clean, readable, and modern Java code.